We all know that red, green, and blue are primary colors. Cyan, magenta, and yellow are secondary colors. Mixing primary and secondary colors creates tertiary colors. For example, as you can see here, orange is a tertiary color formed by mixing red and yellow, and violet is formed by mixing magenta and blue. Now, if we completely remove red from the image, as you can see, the orange areas should turn into shades of yellow because orange is a mix of red and yellow. Similarly, if we remove blue, then instead of violet, we should see a shade of magenta. Similarly, let's remove green. Observe carefully. After removing red, green, and blue, you won't find any of these colors in the image anymore. You can compare the before and after results. Now, let's understand what we know from basic theory. If we remove red, green, and blue again, you will see that the remaining areas turn gray. We all know that blue has the lowest luminance value, followed by red and then green. Here, you can see a dark gray area. What should be the value of this gray? It should be 29. Now, why 29? It is derived from the standard grayscale conversion formula. When we calculate it using this formula, we get 29. If we move the cursor over this area and press Alt+A, you will see in the status bar that the value is indeed 29. Similarly, the red value should be 76. And when we place the cursor over that area and press Alt+A, the status bar shows 76. The same applies to green. If we press Alt+A, we get a value of 150. This confirms that we are removing colors completely and correctly based on theory. Now, let's try doing the same in Photoshop. On this same image, we will go to the Hue Saturation settings, select red, and decrease its saturation. After reducing the saturation, you can still see red in the orange areas. Similarly, if we try removing blue, you will notice that violet still contains blue. Both red and blue have the same gray values here, which shouldn't be the case. Blue should be lower than red. According to theory, colors are not being removed correctly, and colors from tertiary colors are also not being properly removed. Now, let's go to Selective Color, remove red, and observe that red is still visible in the black areas and also in the gray areas. Plus, the entire red area has turned black. Image before and after. You can see that colors are not being removed according to theory, and complete color removal isn't achieved. Let's go to Filter, Camera Raw Filter. Navigate to HSL and decrease the saturation for red. You'll notice that red hasn't been completely removed. Similarly, in the Color tab, selecting red and decreasing the saturation yields the same result. Now, you might wonder, colors are being removed according to theory, but what's the benefit? This is useful in biomedical research, robotics, and the development of different image processing algorithms. Let's explore how it proves to be beneficial in image processing. Here, we have duplicated the original image and renamed it. Now, let's reduce the red luminance using the HSL adjustment through the camera filter. We go to HSL, Luminance. Reduce the red luminance. You can observe that the gradation is getting destroyed and pixelation is occurring. Let's apply this change and see where else we can decrease red luminance. Next, we'll try Selective Color. We will go to Selective Color, check the absolute option and decrease the luminance. Now, we will go back to selective color, select relative this time, and decrease the luminance again. This is the original image, and now we will send it to Pixmaster. In Pixmaster, we will navigate to Luminance Adjust and decrease the red luminance. Relative checkbox is not selected. We will apply the changes and send the image back to Photoshop. This is the absolute adjustment, renamed Pixmaster A. Now, let's send the original image to Pixmaster again. But this time, we will select the relative checkbox before reducing the red luminance. We will apply the changes, send the image back to Photoshop, and rename it as Pixmaster R. Now, let's compare. This is the original image. We can observe that there is a lot of information in red color. As observed, reducing red luminance with HSL caused a loss of gradation. Let's check the selective color absolute result. Zooming in. Black details appear in some areas. We select Pixmaster A, an absolute adjustment. This is the result of Pixmaster. And this is Photoshop's result. Lots of black information on the edges. Let's observe bottom area. This is the original image, which has multiple white reflections and strong edge details. This is Pixmaster absolute result. The white reflection and edge details are still visible. Let's observe selective color absolute layer. You can see that it turns highlights into black and edges are also darkened. Pixmaster's result. And this is Photoshop's result. Now, let's compare the full image. Original image, Pixmaster absolute. Selective color absolute. Next, we compare Pixmaster R relative. Zooming in. As you can see, there is a lot of information. Notice how the gradation from dark to light is properly maintained while still retaining important details, including reflections. Now, let's look at Photoshop's result. You will observe that the gradation is not properly maintained, and significant information has been lost. This is original image, Pixmaster result. Photoshop result. Zooming out. Original image, Pixmaster result. And this is Photoshop's result. We can see how proper color separation allows for the development of more advanced image processing technology.